Before we start, I wanted to do a very quick announcement in that I am right now working on an experiment that then I will potentially link it to some of the work that I've been doing in regards to symbiotic intelligence, and I'm looking for volunteers. And if you or somebody you know would like to be part of it, in probably by next week, I will have a Google form where you could sign up for it. And in terms of the time engagement for you, it's really not a whole lot. Maybe it takes about 2 minutes a day for you to do it. And then it's designed to go from anywhere between 1 to 3 weeks. But every day it just needs you to do something for like 2 minutes and then just document the interaction that you have, for example, with Instagut in this case. And that will help me gather some information about the internal state changes that is happening during the decision making that, for example, you, if you volunteer, would be having. And that gives me enough data for me to write my next paper regarding the symbiotic intelligence. So if you're interested, please keep an eye on it, and I'll definitely make a bigger announcement next time. Without further ado, let's go into today's topic. Perception is often thought of as a very straightforward process. For example, we say that we see objects and the brain process that information, and then we become consciously aware of what we are observing and what we are seeing in front of us, for example. But recent research challenges this simplistic view in that they try to demonstrate that perception actually depends heavily on the brain's ongoing spontaneous activity even before an object appears in front of us, for example. Using ultra high resolution fMRI machines, the authors of this paper examine how pre-stimulus brain activity influences our visual perception and our visual recognition and categorization, and to some extent our conscious awareness. The findings here provide a critical insight into how internal brain dynamics prepare our system for incoming sensory information, and that they carry important implications for the development of, in this case, for example, the future of AI and humanoids and AI systems that interact with humans in a deeply adaptive as well as state aware way. And today we're going to talk about this paper, and we'll also connect this paper at the end with what we are thinking about the next generation of AI systems. This study focused on the threshold levels of perception, visual perception task, in which the participants of this study were asked to recognize faint or difficult to identify objects. These individuals then underwent fMRI sessions where their brain activity was observed. And as you know, fMRI looks at the blood flow as well as the oxygen level. And the analysis here revealed that pre-stimulus activity across the brain networks, including the visual cortex, the default mode network, and other network within the brain were actually influenced by multi aspects of perceptual performance. Especially ongoing activities were shaped by, for example, sensitivity. In other words, how easily the participants of this study detected the stimulus to be, their decision criteria, how liberal or conservative participants were in reporting that they saw something, that they saw an object, as well as categorization accuracy how accurately they classified the stimulus, the objects that they saw in the study. This study also highlighted the pre-stimulus activity that do not simply add linearly to the stimulus that was evoked for these responses. Instead, spontaneous activity interacts with incoming sensory input in complex and non-linear ways. And in essence, the brain's initial state before they saw the object determined the trajectory of how that stimulus or that object was processed within the brain of the individual. This challenges the traditional view of perception as a purely feed-forward process and emphasizes that conscious recognition emerges from dynamic interplay between ongoing activity and incoming sensory input. These findings have significant implication for how we understand conscious perception. They suggest that our awareness is not just a product of sensory input, but is actively shaped by internal brain dynamics that fluctuate from moment to moment. This research supports the idea that the brain maintains a continuously active state, preparing for and modulating responses to the environment rather than remaining in a passive resting mode until stimulus arrives. This also provides insight into perceptual variability. The same stimulus or the object can be perceived differently depending on the brain's ongoing activity at the exact moment that it's, for example, observing an object. This might help explain why identical sensory events can lead to different perceptual experiences, such as in cases of attention lapses, fatigue, or altered state of consciousness. It has also relevance for understanding perceptual abnormalities like hallucinations, which may involve internally generated activity that overrides the external sensory input. Now, how might we connect such studies, going back to symbiotic intelligence, for example? In this case, because symbiotic intelligence principle, it's based upon intelligence system building for humanoids, as well as them being connected to biointelligence or biological intelligence, they would be able to, in this case, interact with humans in a state aware and adaptive manner. The findings from this study, for example, provide a concrete scientific foundation for this approach, where humans are not static information processing machine, but their perceptions, their decisions, and their behaviors are continuously shaped by internal physiological and neural states. To interact effectively with humans, intelligence systems then need to account for these internal states in real time. And so pre-stimulus brain activity, as shown in this research, is linked to measurable physiological signals, including heart rate, for example, pupil dilation, or neural oscillations, aka brain waves. By integrating these biosignals, humanoids can then gain insights into the human's internal state and adjust their behavior accordingly. For example, a humanoid could modulate its instructions, prompts, or social signals based on users' attention, their level of awareness, their readiness to perceive and respond, and so forth. This study also supports the concept that human perception is non-linear and context dependent. This means that humanoids, for example, designed with symbiotic intelligence principles in mind, should not rely solely on external cues or deterministic algorithm. Instead, they should combine internal biosignal monitoring with external sensory input to adapt to the user's moment-to-moment state of mind and state of being. This creates a symbiotic loop in which the machine aligns its action with the human's current cognitive as well as perceptual readiness. And in practical terms, this research provides evidence for the feasibility of potential symbiotic intelligence in that it shows that internal states meaningfully influence perception and decision making, that these states are measurable, and that the systems that account for them can interact in a more human aligned and effective way. This move symbiotic intelligence from concept to science backed strategy, for example, showcasing that potentially there are ways in which we could make these interactions happen between the artificial systems as well as the biological systems. To sum up, this particular study reveals that the brain is a constantly changing state dependent system where ongoing spontaneous activity shapes conscious perception as well as decision making. These findings underscore the importance of considering internal state when understanding human behavior. For symbiotic intelligence, as we mentioned, the implication is clear. Humanoids, future AI systems, and intelligence systems must integrate internal human signals to interact optimally. By doing so, they can indeed align with the human perception, the human attention, as well as decision making, creating a truly adaptive and symbiotic form of intelligence. That's all I have for today. As always, I will link the research paper below so that you could read it for yourself. And again, feel free to like, comment, and share. I really appreciate your engagement in this channel.